All right, in this video, we're going to be looking at an area model and how we're going to use that to represent probability. This is from your ebook. It says one way to represent a sample space that has outcomes that are not equally likely is by using a probability area model. An area model uses a large square with an area 1. The square is subdivided into smaller pieces to represent all possible outcomes in the sample space. The area of each outcome is the probability that the outcome will occur. And then it gives us this example here. It says 1/4 of the population can bend their thumbs back, and you'll notice that is labeled here. And then 3/4 cannot. So 3/4 is no and takes up that chunk. How should the diagram be altered to show that 7/10 of the US can roll their tongues? And if I look here, this is labeled, so I need to, again, put maybe a yes and a no. So as we make our area models, requirements are my sides have to be labeled, both with what they are and with their probabilities. And it looks like 7/10 are a yes. So I'm going to do 7/10 here, which means then that 3/10 would be no. So I'm going to split that at roughly 70 and 30%. And then the relative probabilities for different outcomes are represented by the areas of the regions. The probability area model representing people with both special traits is the width of 1/4 and a height of 7/10. So to find these, I'm going to multiply these probabilities together. Little mini fraction lesson to multiply fractions. I multiply numerators and denominators. 7/10 times 3/4 is going to be 21/40. And then 3/10 times 1/4. And I think for these, the fraction's not too messy. It's nice. It's neat. I'm going to leave it in fraction form here. But I think the next one I'll show you, I'll change it to a decimal. So I can see my various probabilities. And if I check 7 plus 21 is 28. Plus 3 is 31. Plus 9 is 40 out of 40 is what it adds up to. I'm checking that my area is 1. And that's this question here. What is the area of the rectangle? 1. That's the area of the entire square. And then the probability that someone has both special traits would be this chunk here, which would be 7 out of 40. What is the probability that a randomly selected person can roll the tongue but not bend their thumb? So I'm going to look for a yes on the roll their tongue, but a no on the bend their thumb. And that's going to be that large chunk there. That's going to be 21 out of 40. And I got that by looking right there. Okay, we'll look at one more and then I'll have you do another one. This is the one where I think I'm going to go ahead and do decimals. So this one's already split up for me. It's got two different blood types, blood type O and blood type A. As I look at this, these are labeled on both sides. We have person 1 and person 2. And I think what I'm going to do is I'm just going to multiply them here. I'm going to call it 0.73 and 0.27. If I multiply 73 over 100 times itself and turn that to a fraction, that's going to be a bigger fraction with more numbers in the denominator than I'd like. So I'm just going to go 73 times 0.73, and I'm going to list out all my decimal places here. For this one, I'm going to take 0.73 times 0.27. Oops. And that's going to be 19.71. I could put it in as a percent or as a decimal. Either one is fine. I'm going to take 0.27 times 0.73. And that, of course, is going to give me the same thing. And then I'm going to take 0.27 times 0.27. Now, if I wanted to know, in this case, the probability that they had the same blood type, that would include like both having blood type O or both having blood type A. If the question, what is the probability that's selected at random that they have the same blood type? I'm going to look at this and I'm just going to add those two together. Oh boy, you get to watch me struggle with this. Plus 0.0729. So that is 0.6058 or 60.58%. Okay, so I'll leave some for you to do. I just wanted to give you a little overview of it. I'll do one more here. We'll learn more about a tree diagram in the upcoming days. So we're going to make an area model for these two spinners as shown. So I'm going to start by building my square, and then I need to label them. I need to label spinner 1, spinner 2, and then I need to label my fractions here. 1, 2, 3 from spinner 1, and they're all equal, so they're all a third. And then for spinner 2, I'm going to label 1, 2, and 3. 1 looks like it's a half. So again, I'm labeling the probability and the outcome. 2 is, let's see, then I have 3, which is a third, and 2, which is a sixth. Okay, then to complete this area model, I need to fill in the probabilities on the inside. So this is a half times a third. That's going to be 1/6, and these are all the same across here. This is going to be a third times a third for this chunk here. A third times a third is a 1/9. And since this top row is all the same, these rows work out to be the same here. And then a 6 times a third is 1/18. So that gives me all the different possibilities of what I get on spinner 1 combined, spinner 1 combined with spinner 2. And then it asks me to find the probability that the sum is greater than 4. Well, if I'm adding these numbers together, let's see, if I get a 1 and a 1 here, that's going to make a sum of 2. A 1 on spinner 2 and a 2 is going to be 3. So I'm just putting like what the sum is. 3 plus 2 is 5. 3 plus 3 is 6. 2 plus 1. Again, I'm adding my outcomes here and just marking it in the upper right-hand corner. Okay, sum greater than 4. So I'm going to go through and I'm going to highlight these. The sum greater than 4. That doesn't include 4, so that's just a 5 or a 6. So what I'm going to do down here is I'm going to do a 9th plus a 9th plus an 18th. And then I'm going to just add those together. I'm going to do 1/9 plus 1/9 plus 1/18. And then I'm just going to do math fraction. And it's going to give me that in simplified fraction form. Okay, I hope you found this helpful to figure out what needs to go on an area model. The spinners need to be labeled, the top and the sides, with what it actually is and with probabilities. And then the inside probabilities need to be calculated. Okay, we will practice more of this in the coming days, but for right now, that's a good start. Thanks for watching.